Welcome back, everyone. We're here with Chi Lu, the Executive Vice President at Microsoft, who oversees research and development for Microsoft Office, Office 365, SharePoint, Exchange, Yammer, Lync, Skype, Bing Apps, MSN, and the advertising platforms. So Chi Lu oversees an enormous amount of software development at Microsoft. And he used to work actually at the Google X project as well with a friend of mine, Tom Chi, who will be joining us later in the conference.
Tom is one of my favorite colleagues I worked with before. He's totally awesome.
He's incredible.
Yeah.
I'm a huge fan of Chi and his work. He comes from an engineering background and has an unprecedented amount of knowledge. I learn a lot every time I talk to him. He received his PhD from Carnegie Mellon University in 1996, and he has a very tight schedule, so he'll only be here for about 45 minutes or so. But we're very grateful to have him here to share his wisdom with us today. So thank you, Chi.
Oh, thank you very much, Ed. For organizing this to begin with, I thought it's incredible event you're doing for our developer community. I'm personally grateful to what you have done, Ed, and certainly very much honored to have a chance to speak to you and through you to the developer community.
Thank you, Chi. So let's start off by, there's going to be a fireside chat where the audience will be able to ask questions, and then we also have polls going to the audience right now as well. So feel free to answer those polls. And then we'll go back and forth between my questions and audience questions.
Yep.
So Chi, maybe you can tell us a little bit more about your day-to-day job responsibilities at Microsoft so that we can have more of an overview of what your work is like at Microsoft.
Yeah. So you already described a little bit about my overall responsibility, the type of products that I'm responsible for at the Microsoft. The day-to-day, I spend a portion of my time with my leadership team and people in the organization deciding our strategy and the product roadmap. And another portion of times is on technological roadmap, particularly for areas whereby it requires longevity of the investment. Things as big infrastructures or set of core algorithms investment, for example, some of the recent AI technologies, I tend to spend more time on those. And I also spend quite a bit of time with my teams, organizations on the engineering systems. We have regular cadence, have regular reviews with my teams about the engineering tools, engineering processes. For teams doing services, we also have dedicated forum for DevOps related activities, live sites and all those. So my time kind of spreads. One thing I will confess up front Ed, to you is unfortunately I'm no longer coding anymore. So I usually feel like I'm more of an overhead versus to be useful. But regardless, that's kind of a current description of what my day-to-day work is. I always interested in learning from my colleagues at the Microsoft, understand what's on their mind. And as part of my job, I want to do my best to make sure that the developers in my organizations really have good tools, they have good experiences, and they can move at a fast cadence. We are making some progress. Honestly, we are not there yet. There's a lot of work we need to do to scale the system that we have so that my teams can innovate at a much, much faster pace over time.
Great, thank you, Chi. And so, there's a lot of engineering leaders in our audience who are working at medium to large companies. And, every day they have software development challenges ahead of them. And, leadership and leadership of their organizations is something that they're always learning about and trying to improve on. So I'd like to just learn a little bit more about how you're able to effectively lead such a large software development organization within Microsoft. Like, what are some best practices that you use? What's it like to organize all those different R&D initiatives?
Yeah, so this is just my thoughts, my own learning. I would say the caveats, my thoughts also evolving. I learn more from my own practices, learn from the people that I work with. Essentially, my view on this is your job number one is to understand the core product, the business your organization is in, and design your organization, more important, the engineering system that scales with the business, with the product. And specifically for my job at the Microsoft, so first thing I need to focus on is understand the type of engineering system that we need. Because often it's, in order to scale, not one size fits all. For example, within my groups, we essentially build 4 different types of engineering systems. One is very large scale cloud services. For example, the Bing search engine, Office 365. They have one set of engineering tool systems that we built to scale that. And the second is we have what we call deep clients, like Office client. These are very, very heavy clients, huge amount of code base. In itself, they are in many ways like the operating system itself. They build their own abstractions, layers of abstractions. So make sure that we have the engineering system that we can truly do a good job. Our code stay in healthy state, and we can have the agility, pace innovations for our deep clients. I'll talk about a little bit later some of the things we do. And then we have one more type of engineering system. Essentially, probably only Microsoft, a few companies will do. We ship servers. We ship SharePoint servers, Exchange servers, Link servers. These, again, different. We ship still at this point, people may not believe that we still once every 3 years, because enterprise customers, they actually, you have to understand that they are natural pace of adopting new technologies. Kind of designing the engineering system cadence fits their needs. So we have one set of engineers, engineering systems really designed for making sure we can ship servers. That's kind of third type. And the fourth type is large infrastructures. Essentially, our cloud fabric manage very, very large scales, all the different hardware, network devices, data centers. Again, it's its own set of cadences that we need to manage. So once we understand those, then I will spend time with my leadership team to understand for this type of engineering system, what are the important tools that we need to design so that we can scale the team, scale the product, and scale the business practices. And it turns out that each of these 4 different types of engineering systems, they're all kind of different. You kind of have to understand, I have this concept of the natural cadence. Essentially, your product, how that meets with our customers, at what pace they adopt the new technologies, at what pace you can actually harvest the economic value, because product marketing, monetization, usually, for, as you mentioned, for medium-sized company, you can't really separate all these things. So you have to do them together. So being very thoughtful of understanding the innate needs of the customer, how you drive innovations, and you design the tools and design the engineering processes. The goal that I optimize for is, number one is developer productivity and developer experience. I personally, at this point, will give myself still low grades. We're improving, but I thought that we have still a long ways to go to improve our developer experience, to truly make sure that people are really happy with the tools, everything zippy, works well. So that's number one thing I need to optimize. The second thing I want to optimize is the overall ability to meet business needs. That I will focus on planning, making sure that the engineering plan, you minimize the back and forth. The thing I hate the most is you change the plan. That people are already coding, so you want to make sure that your system you design can harness the most amount of engineering resources. And one of the long-term goal I have for my organization is just to ever raise the heartbeat of innovation, particularly at some point, maybe you and I can dive a little bit. For my system, I have this concept of inner loop and outer loop. Essentially, inner loop is where developer hits the key, return key to say, check in the code. We go through a whole bunch of automated testing validation systems so that we can deploy the code either into our production or into the code branches ready to ship as a client code. And then the outer loop is the first bit. The bit gets used by the customer, the feedback data come back. So we are at the early phase of really optimizing on the inner loop, because you want to turn as fast as you can. Developer can really try new ideas, raise the innovation hobby. And then outer loop is get feedback from customers, and we can improve on our current product and finding new ways to generate customer satisfactions. So that's kind of give you a high level sketch of ideas. There's a lot of things, if the audience is interested, you're interested, we can dive deep. But these are the things I tend to focus on, making sure that even though the organization is large, but if you distill down, if you understand the innate nature of the system you try to do, you will be able to find the area you can drive real improvement of the outcome that we all care about.
Absolutely. And so when you're innovating at Microsoft, just to kind of follow up on that answer, is it sometimes challenging for large organizations to innovate? How do you encourage innovation at a company the scale of Microsoft?
This is a great question. So the way I've been thinking about innovation, the system I use, actually, I'm a little geeky in the sense that I try to design a system so that I can be very systematic. So for large-scale organizations, there's four types of innovations. Essentially, we have kind of four quadrants. So we put our engineering resources, we have kind of different approaches thinking about innovations. One type of innovation is essentially the industry is going through a secular change. Let's say everything moved to mobile, everything moved to the cloud. It's a new wave. In those type of innovations, our job is to make sure that Microsoft, our product, creates the maximum amount of distance towards our competitor, meaning it optimizes for separation. We only ship things when we really think our features or our scenarios is substantially better than available on our market. So we're kind of aiming for separation. How far away you can spread your offer, my offers versus other offers. That's one type of innovation. The second type of innovation is for products that's mature. Let's say on-premise servers, perpetual clients, these things been going on for 20 years. It's more incremental innovation. For those, the speed of adding new features, meeting customer demands, and the low-cost speed is finding better ways to raise the speed is kind of the main form of the innovations. The third type of innovation is what I call the drive for either economic gains, meaning that we save cost, you find a new way of doing things, we can reduce cost, or we can create a more economic yield. Essentially, these are really what we call productivity. Essentially, we'll spend engineering resources finding better, clever ways to do things. We can be more efficient, either make more money or save cost. And the last thing is incubation, meaning that think a little bit of blue sky. Think about what could have been going done. We do a lot of garage, hackathon. The odds are low these things will become big, but you have to keep swinging, keep back. So overall, there's kind of four types, and you kind of want to have different way of organizing all those, and often you have different type of leaders to be in charge of these areas. So that's kind of, I've been doing that kind of practice for, even when I was Yahoo, I was using similar approach, because when you get to a certain size, you can't, my view is you can't really say that's how we innovate, because it really depends on what you try to achieve. And the four quadrant things, for me personally, is one of the more effective way for me to organize the engineering team.
Makes sense. And so with the recent kind of trend towards open source that, and professional open source that kind of started with JBoss and has evolved over the last decade or so, how has that open source movement changed Microsoft's perspective? And what's Microsoft's position these days on open source?
Yeah, so this is a great question. And it's a very, very important one. So given what I learned from Microsoft history, because I wasn't around all the way the entirety of Microsoft history. For me personally, maybe before I answer your question, personally, I went through a learning journey myself as well. Even when I was at Yahoo days, Yahoo was one of those companies who adopt open source code, but they actually don't do a whole lot of open source themselves, making the code available. But my Hadoop experience, the Hadoop community came from my Yahoo search team. Was many ways a historical accident. It wasn't like we thought about this thing would be great. It just really was an accident. But along the way, interacting with the Hadoop community, I learned so much. I'm personally much more convinced open source has a lot of goodness and the values on how we write software. In many ways, open production of IP is general phenomena. There's open source movement for producing musics, pharmaceutical products. There's a lot of goodness. So I very much would like Microsoft to move towards, my teams are moving towards that. Microsoft as a company at this stage is very much embracing open source and support open source, because we fundamentally see the world is embracing and changing towards open way of producing software. And a lot of our customers, a lot of our partners are all using open source approach to write software. So specifically our company supporting open source on two fronts. One is the enablement. All you have to do is look at our Azure cloud. We are supporting open source in a big way. We fully embraced. Not only you can run Linux VMs on our cloud, we are also providing Azure support for a lot of open source software, different kind of databases, different kind of systems, because we ultimately want to make sure that Microsoft innovation can ultimately make a difference in our customers' outcome, what they care about. And a lot of our customers care about using open source software. We need to do that. That's number one. Number two, we're increasingly adopting open source software in our own product. More and more product has open source components to it. So for my organization in particular, we are moving really, really fast. This is one thing kind of, for me, I've been working with my leadership team, pushing really, really hard because for organization like my organization, which is so big, open source software has a lot of benefit. One is you don't have to write the code that people already wrote the code. Usually these code are of good quality. The second is through using open source software out from outside, and internally we're building something called internal open source. Essentially, we encourage teams to share code. It causes the right engineering culture, right engineering behavior, because in an open source community, when done well, you as a developer, you speak with your code quality. You earn your status through peer respect. And within a large organization, over time, just the human nature, your manager give you scores, give you bonuses, and you will do things to make your manager happy versus your write code, make other developers more productive. So having internal open source culture can also help improve the Microsoft engineering culture so that developers can really just focusing on writing great code, let your code speak for you. And so we are doing a lot of work to push on that front. The last thing I'll say is we're still early. We haven't done a lot yet. We moved to the kind of the next step was not only adopting open source software from outside, Microsoft will also write software in an open way, meaning that we're contributing to open source community. We have lots of ideas, thoughts. Personally, I think in the next year or two, we will make a lot more progress towards that direction, but obviously it will take time. And the last thing I'll caveat to, Microsoft as a company, we still have a lot of our software closed source for a variety of reasons. Some is for strategic reasons. Some you can make a legit case, say, at this stage of the industry, keep it proprietary, we can probably innovate better. So essentially, we want to be also pragmatic and thoughtful, meaning that even though we support open source, embrace it, but at the same time, if there's cases whereby doing a closed matters helps the company in important ways, we want to make sure that we're balanced in that regard. So that's kind of how I think about the overview about Microsoft as a company with regard to open source. At the personal level, I'm very passionate about adopting open source practices, approaches. Particularly, I see the important need for my organizations to move towards that way of writing software.
That's wonderful, Chi. And I just want to make sure the audience knows this, that Microsoft's actually been very active in contributing back to the open source community. So one of the things I noticed over the last few months is that Microsoft created their own branch of Node.js and has made some improvements in relationship with their Chakra project, and has now committed those changes back into the core, which is really fantastic to see. That's an amazing, amazing kind of contribution that you made there, and it's very different than Microsoft's position historically on open source.
Yeah. So we as a company, I think this is a great example. And actually, I'm personally familiar with. I was in San Francisco meeting with some of the key people involved in that particular project. Overall, I think under Satya Nadella, our new CEO, our company is a lot more leaned towards the future, be a lot more open-minded, and embrace things in the past that we wouldn't have embraced. And I think it's great. Our company is moving along well, and our customers, our partners, are responding very positively. Personally, I think myself, people in my organizations, all kind of feel the new energy. That wow, that's really going to be cool if we can do things in that way.
That's great. Now, was it tough, kind of politically, to get Microsoft to really go down the open source path? Because I'm sure that there must have been folks within Microsoft that were kind of used to doing things in a more traditional way and didn't embrace software development. So how can you effectively turn an organization in that direction of that scale?
Yeah, this is a great question. I would say, at my experiences, it is not easy. The key is you kind of have to go through this journey. My own experiences, Microsoft in my view has overall really wonderful employees. They all try to do the right thing for the company. They all aspire to do good things. But we're all human beings. We all come from our own background. If you, let's say, doing certain things for, 20 years, and you are really good at this, and you can make a good argument to say why this thing makes sense. and it just takes time. So I think our fundamental approach is, from leadership standpoint, be clear to the company to say, this is the future, let's embrace that future. And then have just a respectful dialogues to say, understand your point of views, understand these things are absolutely have legit point of views. But having said that, let's work together, let's design a path so that we can move our heritage of the past in some ways, instead of view that as a baggage, somehow turn that around as an asset. But with that open mindset, with that learning approach, and for example, one thing our CEO is pushing for the company is, as a part of our new culture, is to have what's called a growth mindset. Believe yourself, you can always become better. You can always learn new things. So I would say it's a terrific question. It's definitely not an easy journey, but as long as we are focused on having a respectful dialogue, pushing ourselves towards the future, over time, I think we will be able to get there. And I do think we're making good progress as a company right now.
That's great. Wow. Okay, so a couple other questions from me, then we'll go to the audience. So, there's a lot of developers in our audience that are aspiring in their career these days. And a lot of them are, some of them are students who are new to software development. Some of them are professionals who've been in the industry for a while. Do you have any career advice in general for developers to make a very successful engineering career for themselves?
Yeah. So I would share with you, this is, Ed, I give the same set of advice I'm about to say pretty much to every of my friends, people on my organization, even my daughter, she's a developer. She works at startup. Last night I was talking to my daughter about the same thing. Essentially, this is kind of my own learning myself, particularly together with my colleagues in the past. So summarize the 5 points as my view of building a great developer career path. Number one is excel your core domains. If you're a database person, you really need to do everything you can to be the very database person. If you're a networking person, just to make sure that whether you're performance engineers, whether you're a front-end person, just to make sure that you truly practice your art, you can do the very best you can. So it's very important. You have a foundational strength in what you do. The second, have product sensitivity. My honest feedback to all the developers, if you do not understand your product, my view is ultimately you don't get to be the great engineer, because understand how your customers are using your product, being able to develop this, Jack Welch called it the sixth sense, anticipating the future needs of your customers. And then you can extrapolate, you can architect your code base to anticipate future changes. But without having real good depth understanding product, it's very hard for you to be able to do that. So there's a lot of engineering practices I do. For example, for people who work at search engine, I always say, you have to have a daily ritual. You write code, back end, front end, it doesn't really matter. Your daily ritual, anytime you get up in the morning, take 5 queries from random sample from 5 queries, do comparison on your own search engine versus the competitors. If you do better job on the competitor, you always answer 2 questions. Why you are better than the competitors? And second, how can you be 2 steps ahead? If you're behind the competitors, answer the 2 questions, why you're behind, and what it takes, the second question, what it takes to get back. My experience is, if you do that for 3 months, you start have 2 intuitions. You do that for a couple of years, you clearly see how the web structure look like, what people are looking for, where the places, information have more needs. But that won't come until you really pay attention to the product. For people I'm working on mail, you're always going to be focusing on what kind of scenarios, why people respond email in certain ways. It doesn't matter what product it is. As an engineer, you always have to live in your product, understand with deeply. That's number 2. Number 3, you have to understand the business. You have to understand how your product makes money. I learned this in a brutal lesson. In Yahoo days, Yahoo had 3/4 way off people. Even though we thought that we're doing good work, our user base is growing, but ultimately the history is littered with great product. The business doesn't make it. If you can't make money, in the end, it doesn't matter. And in modern products, the monetization experiences, the monetization capability, whether it's a payment, advertising, you kind of have to design into it. And I forgot to mention in the experience side, telemetry, analytics, where you put instrumentation code, you really have to understand the product to say where you put those code. Without understanding product, you would treat this as a burden. I'm going to just code the features versus adding telemetries. So understand the business, in my view, is an important part of enable you to be a great engineer, because that's very important. The 4th one is be resourceful. meaning that develop this mindset. Nothing stand in the way. You can always do what it takes to get things done. It's very important, particularly as organization grows. There's always barriers. There's always roadblocks. You probably kind of know that in life there's two kinds of people. One kind of people would say, let's say you as a leader to say, your manager talk to the employee to say, I want you to do X, Y, Z. One kind of people to say, okay, I got it, and this person disappears. 2 weeks later, say it's done. What's next? Another kind of people, 30 minutes later, come back to say, you told me to this, now I'm got blocked. I don't know what I do. You explain to it, this is how you do it, and 30 minutes later, this person come back again. So you cannot be successful, be a great engineer if you're that kind of people. You really have to have the mindset. It doesn't matter what it takes. Get things done, get the outcome. So be relentless about removing barriers, being resourceful. That's number 4. Number 5, in my views, in our collective experience, sets truly a good, strong engineering leaders with great ones being inspirational, meaning that being able to articulate a thriving future, very, very compelling to our colleagues, get people energized, motivated. And my experience is that when people are fully energized, inspired, motivated, the quality of the work, the pace, the energy is so different. So for anybody who are developers right now to build, in my view, build a thriving careers, these 5 things will pave the way for the long term. So I can't take full credit for myself. This is my learning together with my colleague back at Yahoo. His name is Jeff Weiner. He's at CEO of LinkedIn right now. So Jeff and I, we use the 5. He's a baseball fan. He called a 5-tool player. It turns out in baseball, there's 5 skills, like I think hit, run, throw, field, catch, I think. But it turns out that very few people good at, excellent at all 5 of these things. So I think for developers, similar. These are the 5 things. But I think everyone can do it. You just have to be intentional, invest your energy in the powers, dedicated, and you all have thriving careers ahead of you.
That's great. Thank you so much, Tom. So we have some audience polls here that we can get answers to here. So we started to ask the audience as you've been speaking, what programming language do you use primarily? And number 1 is JavaScript. Number 2 is C# in the .NET stack. Number 3 is other, and then Java, then C++, then Swift. So it's a very nice mix here in the audience that we have.
So for me, among those language choices, the one I use the most is JavaScript. I personally will confess, let me just be very clear. I think JavaScript as a language is ugly. I don't like the language, but I like the tools, all the modules. It's just ironic. Historically, you have a lot of those examples where the language from design perspective is really not nicely designed the language. But the community is so powerful. Now there's so many modules, code available. So JavaScript is number 1. The code, the language I use the second most is not C# per se. I'm more of a C++ person. I do a lot of Java, C#. I'm confess to myself, I'm a little bit old school. I wrote a lot of C code in graduate school, C code when I was at IBM. I worry about, in my view, we need to be careful. If you're in a loop, if you have a system that's super, super tight, in my view, to be very, very careful using managed language, because a lot of times, because you can't really control how garbage collection truly works in those environments. So even if you really want to use Java or C#, I kind of highly recommend that you kind of allocate a heap for yourself, just to make sure that you can control some memory allocation, deallocation behaviors from the code itself, because otherwise, it's hard to control the behavior of the code. Swift, honestly, I don't know much about. I was just asking people to give me feedback on how that works, and I confess I really don't know much about that language.
Mm-hmm. I agree with you on JavaScript, by the way, and also Go is one that I'm particularly passionate about.
Interesting. My daughter is doing Go now, so I'm gonna learn from her. So
that's great. Yeah, like what I think is really interesting about JavaScript is that even though the language is crappy, and I kind of agree with you on that, like the syntax is pretty bad, right? It's not a modern design language, but there are so many programmers out there.
Oh yeah.
That are fluent in JavaScript, because everyone has to know a little bit of JavaScript to be dirty, to be dangerous, and to build web pages. And so all those programmers can now build server-side applications with Node. And so politically, that's a huge force to reckon with.
Yeah, actually, I 100% agree. And maybe say one more thing. My team's doing some of the work. The last point you just mentioned, because with Node.js, it's kind of de facto middleware on the server side. But if you have a VA engine or the Microsoft JavaScript engine on the client side, if you truly using microservice-oriented architecture of your code, the beauty of this is the same services can mobile now, can run on the client. And our Cortana, Microsoft this Cortana agent, a lot of Cortana code is like that. So it's great because you can move the code around, sometimes run on the device, sometimes run on the services. And that's kind of the beauty. The key power of JavaScript is really its ecosystem. So many participation, there's so many things you can just reuse, take advantage of.
That's great. So let's keep going here on these polls. So the next poll is, what devices are you developing for? So this is actually kind of surprising to me. I didn't think it would be like this, but it looks like there is an overwhelming majority of people who are building for desktop, which I assume includes servers as well. And then second comes in mobile, and then tablet, and then other, and wearable is very tiny right now. And so there's actually, so what this is telling me is that a larger percentage of our audience is developing systems either for the desktop or I would assume for servers, and that there's probably a 2-to-1 edge for that over mobile right now in our audience.
Is this, let me maybe double check the question. Is this the code you're targeting for what kind of devices? Targeting for mobile, targeting for wearable, targeting for PC?
Yeah, it's devices developing for, that's right.
Oh, okay, so targeting, yeah. So
yeah, people aren't programming on their tablets, I would say.
I was like, how do you program on your watch?
Is that even possible these days? I don't even know if it's possible. It would be hard. I kind of need the fast response of the keyboard.
So, for my organizations, let me say two things. One is our current business core base is really PC and the cloud services, meaning that Office 365, a large majority of current customers using PC or laptop to consume. Increasingly, there's more mobile endpoints, but by and large, and a lot of our code is targeting cloud infrastructure, targeting Microsoft's own cloud. So, but we know the future is mobile. We really have to make sure that Microsoft, all the key software experiences really runs well on mobile devices. And our key approach is, and this, by the way, can be controversial. So there's a lot of discussion, debate, even with my own teams. We kind of go back and forth. Essentially, one part of my organizations took approach whereby we essentially build a platform abstraction layer that try to build in a way so that you can really share across iOS, Android, and the Windows Universal. So the best example, it's pretty amazing. It's really impressive. Better than I really anticipated. It took about us 2 years to achieve this. Essentially, our Word, PowerPoint, Excel, these 3 core apps, our mobile devices were able to share more than 90% of the code across these 3 different platforms. And that's very, very amazing because initially I didn't expect we can share that many because the platform can drift apart. So it really depends. And you also want to make sure that your abstraction isn't kind of the lowest common denominator. You lose a lot of the experience, the fidelity, the performance nature of those experiences. How do we balance the two? So in some ways, we want to target our code base towards where our customer is, and increasing our customers using phone more and more. Even though today our large mixture is still targeting for cloud, targeting for PC, but I see my organizations fundamentally shifting towards phones. In the future, the wearable devices or IoTs, different endpoints.
That's great. Okay, so a few more polls here. So are you building apps on cloud services? And the majority of our audience, about 34% of the responders said, yes, they're all in building apps on cloud. A little bit less than that, about 30%, no, they're not building on cloud. And then 27% are still learning about the cloud. And then 7% are getting started soon on the cloud. So that's kind of how it breaks down, Chi.
That's interesting. To be honest, I would expect that the percentage on cloud be higher than the percentage you reported it, because it kind of depends on target audience. If you're in Silicon Valley, If
Well,
the
actually, there is 27% who are still learning. So if you add that into the yes,
that may be, yeah, that may be higher.
now it's like more like 60% are either
Yes,
learning
that
or
feels,
already all in on cloud.
yes, that feels more reasonable. Yeah.
Okay, great. So the next is, do you use React or Angular, or neither, right? So 12% use React, 36% use Angular, and 51% use neither. And some of those developers may not be building web pages with front end. So that could explain part of that poll result there.
That would be, this is interesting. I think if you poll every year, that would be great to see the. I'm very interested in this because obviously, how do we have the model view approved for deep apps done truly with high performance, but with richness of the experience? To me, is still a quest. I think there's obviously pros and cons about each of those. Every framework has its pros and cons. I'm very interested in learning from the larger developer community. My own teams, we have teams working on different framework, and we try to think about our own frameworks. So that's why I'm very curious to see the collective learnings. And
yeah, it is really interesting to me. In fact, I'm actually a little bit surprised. Maybe I shouldn't be surprised, but I'm surprised that Angular came in so much higher than React, because the general consensus that I've seen in San Francisco, at least, is that people tend to be preferring React a little bit more to Angular these days.
that's what you just said was very consistent with my interaction with Silicon Valley teams. To be honest, even my own teams, there's more people shifting towards React versus Angular. So still, there's a lot of Angular code being done even within my teams, but React is much more of a on the rise at a pretty fast pace.
And it could be a timing question. It could be that there are a large number of deployments. Even at my own company, we use Angular, and there's a lot of investment we made into it, and so that could explain part of the reason why there's more Angular than React. So I think that trend will change. Like, it'd be very interesting to pull this again next year.
Yes.
See if the percentages change.
Yes. Yes.
Yeah. Maybe we can poll tomorrow and see if people change.
Yeah.
Maybe there'll be a 0.1% difference tomorrow.
Yes.
Yeah.
That's right.
So anyway, last poll question is, have you tried any of these machine learning tools? I was kind of curious about if anyone uses machine learning, which is an area of interest to you, Chi.
Yes.
And there weren't that many respondents. There's only a handful of votes here, because I think this is a fairly niche subject for our audience. But most people who responded say that they've tried TensorFlow, and then Torch and Cafe came in last for that.
I see. So I'm also very curious. This one, I think next year would be great. My view on this is, because my personal view from everything I do, I spend a lot of time on machine learning, deep learning related stuff. Increasingly, I think our industry is getting towards a phase whereby we are fundamentally writing a new breed of software. These software can see, these software can listen, they can sense, they run inside a car, inside a toaster oven, Amazon Echo-like devices in June. It's early, but you can just see a wave that will come. And in the future, I think it will fundamentally challenge the way we're engineering software. Because today we write software pretty much based on algebra, based on first order logic. You can have specification, you can reason with mathematics, mathematical properties of each software module. But for those new systems, they're fundamentally learned through data. And the quality, the efficiency really can be hugely different depending on the nature of the data you have, the tool you use, the specific approach. So that's why I'm very curious for my own teams. Certainly we're doing a lot of those work. I think TensorFlow, from what I can see, is kind of the most widely known, popular. It's a very, very well done tools. Microsoft has its own tools. We have our own tools as well. It would be good for all of us to keep in mind. My own view on this is it pays for us as developer community to be proactive, to pay attention to things is going to come. And then hopefully maybe encourage best practices, sharing of knowledges, even encourage people, experts to write already books so that the knowledge is available to a lot of people. It's easy for you to pick up.
Great, thank you, Chi. So let's go to some audience questions here. The audience has been thinking about what they want to learn from you as we've been speaking. So the first question is kind of on timing of open source. So why today? Why is today the time that Microsoft is embracing open source versus kind of in the past in previous years? What has changed within Microsoft, and why is now the timing to do that?
It's a very good question. Thank you for the question. I think I would say the following. First of all, it's not today. I think Microsoft has been endorsing, supporting open source to varying degrees from the past few years already. So it's not like a sudden. I try to make sure that it's not like a binary change. We were not supporting, now we ought to sudden support. That's number one. Number two, part of the reason causing those change, I would say, is leadership and strategic decisions. I do think Satya Nadella, our new CEO, he is fundamental, has a lot more open mind, different points of views, and he really wanted Microsoft to focusing on moving towards a cloud future, embrace future way of doing things, and challenge our heritage, embrace our heritage, but challenge it, bring that around to the future. So I think that's another factors. And the third factors is just internal initiatives. Our employees, when I have roundtable meetings, I have weekly all hands phone calls every week. We do 30 minutes all hands calls. Open source is on everybody's mind. People are like, what are we gonna do? What we do? Because you can just see this is everybody wants to do these things. It just makes sense. So there's multiple factors all coming into play so that our employee can become more productive. Our product can serve our customer better. I mentioned on Azure. A lot of our Azure cloud customers, they want to use open source solutions. We have to embrace that. And we use open source to improve our own productivity. And we also want to strategically do the right thing, contributing back to the open source community. The JavaScript engine is one of the better examples, as you mentioned earlier. So it's not binary change, it's a journey, but I do think our new CEO, the new leadership team, should deserve, in my view, a lot of credit.
I agree. I really admire all the advances you guys have been making there, and it's really great to see that. So thank you for helping the open source community. It's been fantastic to see.
Oh, you bet.
The next question with 100 votes, 102 votes here is, what's the single hardest thing about managing thousands of developers? Because it seems kind of daunting, How do you manage so many people, and what's hard about it? Like, how do you overcome those challenges?
Yeah, so my view, this is just my personal opinion. The hardest thing is always managing people. Because processing tools, they're hard things. Worst come worst, I can just write the code and design the system. Let's do it that way. Dealing with people, to me, is always the hardest thing. I think some of the biggest things you will always, at some point, as a larger organization, you will face that is, often you face the dilemma. You have a brilliant engineer, but this person just doesn't work well with other teams, and sometimes becomes a barrier. Now, you as a leader, what do you do, right? So we face those. I think that's, to me, is one of the common areas of tough decisions that I need to make, always related to people. The other is engineering culture change. I would say these are the two standard, because my teams, by and large, they are all very, very technically strong. They are all well-trained. But we have a mindset that's developed over the last 20 years of developing desktop software. And how do we fundamentally change that mindset to embrace a completely different way of doing things? That's very, very hard. Essentially, we summarize as learning new way of doing things and unlearn old way of doing things. And it turns out the unlearn is much, much harder than learning. So I would say these two things are hard. The rest, these things are hard, like I said, designing system, build system, testing system, all these things takes a lot of time. But ultimately, these things are mechanical, mathematical, technical. You can always do it, but dealing with people, particularly, let's say you have technical fellow, so brilliant, but this person is just somehow doesn't work with the team and be very negative. Now what do you do? Those are the, in my view, and the engineering culture change, embracing future way of doing things. So these are the two aspects I think is the hardest.
That's great, thank you, Chi. So this is one out of kind of my own personal curiosity. So, we've noticed a recent rise in this area of marketplace startups, where you have two sides of a marketplace. You've got a supply and you've got a demand. And historically, these kinds of companies didn't really exist. Decades ago, they weren't there. But now, due to new technology advances and new ideas, you've got companies like Uber being created and other two-sided marketplaces. How do you think that impacts software development and Microsoft? And how does Microsoft think about the whole kind of Uber economy?
Oh, this is a terrific question. I would say, let me see. I have 4 minutes, so let me give you quick answers. I'm happy to do this further in-depth discussion. I think there's two sides. One is what you're pointing to, Ed, is in my view is profound new phenomena. We kind of call it Uberization of the world, whereby there's so many different new marketplaces, whether for developers, for designers, for special skills. Everywhere you have the new opportunity of creating new kind of supply-demand meets software opportunities so that you can unlock a lot more economic value. You and I talked about some of those opportunities. I see really everywhere. So Microsoft definitely is very much excited about that opportunity because we want to build new platforms, tools to help people innovate those spaces. We see this as business opportunities. We're doing a bunch of work in that regard. Having said that, I do want to give a rather technical answers from developer perspective. If you scale your marketplace part at some point, my experience, you need to have a resident economist on your development teams. Just a lesson learned in the hard way, because the I would say in my view, is the very first marketplace product is actually search advertising. The company who invented this is a company called Overture. They invented this bidding-based model using auctions, supply-demand meets. So Yahoo acquired Overture. But Google, in my view, did fundamentally the right thing. I was, at the time, made a ton of mistakes. When I was Yahoo, I said, oh, this thing, no big deal. I just grab a bunch of economic books. I read it myself, start writing code. Ultimately, these things won't work. Then at some point, I said, let's go to a conference, talk to the experts. Like, oh my God, these people know so much about you. You really have to hire the expert. So Google hired Howard Vernon, the chief economist from Berkeley. So later on, I hired several economists on my teams in Yahoo. At the Microsoft, we also have economists on our teams because the economists frame the problem very different from computer scientists. And particularly if you want to deal with supply demand, you mentioned Uber. Uber has several economists. I talked to one of them. They're solving a set of fascinating problems. And these things, if you only know computer science, you really won't be able to, in my view, it's very hard for you to figure out on your own by reading books like I was foolishly trying to do a long time ago. So your job number one as a leaders, you need to bring the people who are trained economists. And these people only find those kind of not theoretical practitioners, and they come in and they work with the product teams. Then you can build the software to truly take advantage of this new phenomenon. There's tons of opportunity for startups, for software developers.
Thank you so much, Chi. So let's see, maybe we'll do one last question in the last minute. Only 60 seconds left here.
Yes. Okay, last question.
What is the future of software development? How do you predict that?
The future of software development, my view on this maybe takes a little bit more than 1 minute. I'm gonna give you a quick answer. I think it depends on where the software is, whether it's a server, cloud, services. I would say two predictions for areas that I think will be big. One is today a lot of people building mobile apps. I think over time most people were building chatbots. I gave a talk yesterday at the Wisdom Conference in San Francisco. I'll be happy to share with that deck what I think is the arrival of the conversation era. Because conversation UI, in many ways, is a lot more better on the phones, on a watch, an ambient device than a graphical user interface. And as developers, I think it pays to understand the natural language and pays to use the available bot kit so that your services, your product have a new channel now to develop. I think that's a phenomenon everybody, in my view, needs to embrace. The other one predict I mentioned very earlier. Essentially, we will deal with a new generation of software whereby machine learning learn the stochastic models, particularly deep learning models, will coexist human engineered software. How do we compose these systems so that these software, when they are running inside a car that's moving, still has the reliability, durability? That's requires a new generation of tools, new generation practice for software engineering. So personally, the geeky part of me is really excited about that part of the future because it means we all get to do new cool things and drive the boundary of innovations.
That's wonderful, Chi. Thank you so much for being here and for answering all of our questions. You did a great job. I'm a big fan of all the new endeavors and initiatives that Microsoft's been embracing. So thank you for taking your time out of your busy schedule to enlighten our audience for that, Chi.
Thank you, Ed, and thanks for the audience for giving me the opportunity. It's been a great experience. Thanks again.
Thank you, Chi.
Okay, bye-bye.
Bye.